Welcome back to Crushing Design Patterns in .NET. In our last episode, we simplified a complex system with the facade pattern. Today, we are shifting gears from structural to creational patterns. We are going to tackle a fundamental question. How can a class let its subclasses decide which specific type of object to create? The answer is a powerful and flexible pattern, the factory method. Let's see how our expert Arohi uses this pattern to build a system that can create different types of documents without being tightly coupled to them. Arohi, welcome. In today's scenario, we are building a document management application. The core of our application is a document processor that can open, edit, and save documents. The challenge is that we need to support different document types, like a Word document and a PDF document, and each one needs to be created and handled differently. How would you design this so that our document processor doesn't need to know about the specific document types it's working with? What's the initial problematic design that a developer might use here?
A common but flawed approach is to put the object creation logic directly inside the client class. The document processor might have a big if-else or switch statement that decides which document to new up. This is a classic violation of the open/closed principle. Every time we want to add a new document type, like Excel document, we have to come back and modify this document processor class. The high-level processor is tightly coupled to the low-level document details.
How does the factory method pattern solve this coupling problem?
The factory method pattern solves this by delegating the responsibility of object creation. It defines an interface, the factory method, for creating an object, but lets the subclasses decide which class to instantiate. It lets a class defer instantiation to its subclasses.
What are the key components of the factory method pattern?
There are four key components. Number one, the product, an interface for the objects we want to create. For example, IDocument. Number two, concrete products, the actual classes that implement the product interface. For example, Word document, PDF document. Number three, the creator, an abstract class that declares the factory method, which returns an object of the product type. Number four, concrete creators, the subclasses that override the factory method to return a specific concrete product.
Let's build it. What would the product and concrete products look like?
First, we define our common abstraction for all documents, the IDocument interface. Then we create our concrete document classes.
Now, how do you define the abstract creator and the crucial factory method?
This is the heart of the pattern. We create an abstract document processor class. It contains the common logic for working with documents, but it declares an abstract create document method. This is our factory method. Notice that the process document method works with the IDocument interface. It has no idea which concrete document is being created. It just trusts that the create document method will provide one.
How do the concrete creators implement the factory method?
Now we create subclasses that provide the specific implementations. We'll have a Word processor and a PDF processor. Each one overrides the create document method to return its specific type of document.
How would the client code use these creators?
The client code now decides which processor it wants, not which document. This decouples the client from the concrete product classes. The client code calls the same process document method, but the underlying object created is completely different based on which processor was chosen.
What is the main solid principle that the factory method pattern enforces?
It's a powerful enforcer of the Dependency Inversion principle, DIP. The high-level document processor is no longer dependent on the low-level Word document or PDF document. Instead, both depend on the IDocument abstraction. It also strongly supports the open/closed principle because we can add a new Excel processor without ever touching the existing code.
How does this differ from the abstract factory pattern?
That's a very common interview question. They are related but solve different problems. Factory method is about creating a single object. It uses inheritance, where subclasses decide which object to create. Abstract factory is about creating families of related objects. It uses composition, where you create a factory that has multiple methods for creating different but related things. For example, a IUI factory that can create both a I button and a I text box for a specific OS.
When should you choose the factory method pattern to solve a problem?
You should reach for the factory method pattern when you have a class that needs to create objects, but you want to decouple it from which specific objects it creates. It's the perfect choice when you know that you will have different variations of an object in the future, and you want the subclasses or the client code to be responsible for specifying which variation to use.
Many developers confuse simple factory with the factory method pattern. What is the actual difference?
That is a very important distinction. A simple factory is usually a single static method in a helper class that contains a switch statement to return an object. It is a creation helper. The factory method pattern, however, uses inheritance and polymorphism. The creation logic isn't in one big method, it is distributed across subclasses. The main difference is that with a simple factory, you have to modify the factory class to add new products. With the factory method, you just add a new subclass, which perfectly follows the open/closed principle.
How do we integrate the factory method pattern with modern .NET dependency injection DI?
Here's the thing. In modern .NET Core, we've mostly moved away from manually newing up our objects. Instead, we rely on the built-in dependency injection container. You simply register your concrete creators as services, for example, mapping our document processor to the word processor using a scoped lifetime. And if your app needs to decide which object to create at runtime, you can inject a delegate or even use a factory-based approach within a manager class. Essentially, the .NET DI container is the master factory that handles all the heavy lifting and object lifecycles for us.
Can a factory method accept parameters to return different variations of a product?
Yes, this is called a parameterized factory method. Instead of a parameterless createDocument, you could have createDocument, a string version. The word processor could then decide to return a legacy Word document or a modern Word document based on that parameter. The key is that the return type remains the abstract IDocument. This allows the factory to handle internal logic and variations while the client code remains clean and focused only on the interface.
How does using this pattern impact our unit testing and mocking strategy?
This is one of the biggest hidden benefits. Since the document processor works with the IDocument interface, we can easily test the process document parens logic in isolation. In our unit tests, we can create a mock processor, a concrete creator, that returns a mock document. This allows us to verify that doc.open and doc.save were called correctly without actually creating real files on the disk or generating real PDFs. It makes our tests fast, isolated, and reliable.
Is there such a thing as over-engineering with this pattern? When should we avoid it?
As architects, we must always consider the YAGNI principle. You ain't gonna need it. If your application only ever supports one type of document and you are 100% sure that will never change, then the factory method is likely over-engineering. It adds complexity and more classes to the code base. However, if there is even a 20% chance that you'll add new types in the future, the factory method is a future-proof investment. Use it when you need extensibility. Avoid it for simple static scenarios.
Arohi, that was a fantastic explanation. You've clearly shown how the factory method can decouple our code from concrete classes, making it far more flexible and maintainable. If you now feel empowered to use the factory method in your own applications, give this video a like and comment below with a real-world example where this pattern could be used. And don't forget to subscribe to the .NET Way for the next chapter in our series. In episode 6 of Crushing Design Patterns, we are going to investigate a pattern that is both incredibly useful and sometimes controversial. the singleton pattern. Thanks for watching. We'll see you in the next episode.